Alright? We can now combine the x position and the y position and write a position function for the projectile. What is the position function? It will be xi plus yj. Alright, before writing down, can we think now mentally, what is the x position of a projectile? X position is Vx0 multiplied by time, which is V0 sine V0 cos theta multiplied by t. And what is the y position? The y position is, if y0 is 0, it will be Vy0t minus 1/2 gt squared. Let's write it down now. Alright, if the ball is at any particular position, it has an x displacement and a y displacement. So if the velocity of the ball at any given time is v, it has an x component, Vx equal to V0 cos theta, and Vy, what will be the velocity here? You see, the x velocity will not change. The x velocity when you hit it is V0 cos theta, and at any other time the x velocity will not change. But the y velocity will change. Look at the equation for the y velocity. We have Vy equal to Vy0 minus gt. Is that right? I think it has gone out of the screen. Let me write it here. Vy equal to Vy0 minus gt. Now, this is the equation that gives you how the y velocity changes. Now, Vy0 is V0 sine theta. So, the y velocity will be Vy equal to V0 sine theta minus gt. Now, tell me, as this object reaches the maximum height, what is the value of Vy? That will be 0. In other words, V0 sine theta minus gt will be 0. Now, if you notice, if you set this V0 sine theta minus gt equal to 0 and solve for that t, what will that t be? It will be the time taken for the projectile to reach the maximum height. Yes. Okay, let's move on. So, at any instant, the projectile has a velocity along the x direction and a velocity along the y direction. So we can write V equal to Vxi plus Vyj. And what is Vx? Vx is V0 cos theta, and Vy is V0 sine theta minus gt. Alright? And what will be its x position? Its x position will be x equal to Vx0 multiplied by the time, which is V0 cos theta multiplied by time. And what is the y position? Do you remember the equation for the y position we obtained? It will be Vy0 minus 1/2 gt squared, where Vy0 is V0 sine theta. So that will be y equal to Vy0t minus 1/2 gt squared. That will be V0 sine theta t minus 1/2 gt squared. Alright, can you now write the position function for that projected object? This is the velocity function. Vector, this is the vector equation for the velocity. V equal to Vxi plus Vyj, where Vx is V0 cos theta and Vy at any given time will be V0 sine theta minus gt. Alright, can you write the position function? This is the x position and this is the y position. So we will write the position function as r of t. Now the position is not x, not y, so we will use the letter r to represent the position. R of t equal to the x position, Vx cos theta times t. That will be V0 cos theta times t. Is that right? Let's change that V sub x to V0. So the x position will be V0 cos theta times t. This is the x position. And the y position is V0 sine theta t minus 1/2 gt squared. And so the position function is V0 cos theta ti plus V0 sine theta t minus 1/2 gt squared j. Once you know the position function, you see, it will help you to solve any type of problem in projectile motion. You must understand the meaning of this projectile motion. Now let me ask you here, what is the value of, this is the y position, is that right? Yes. What is the value of that y position when the projectile returns to the ground? You project it from a point and it goes, reaches the maximum height and returns to the same horizontal level. What is the value of y when that happens? Y will be 0. So when this quantity is 0, what can you say about this time? In other words, the time taken for the y displacement to become 0. What can you say about that time? The time taken for the y displacement to be equal to 0 is called the time of flight. We talked about the time of flight in the beginning. So the time of flight is the time taken for the y displacement to become 0. So if I want to obtain an equation for the time of flight, all I need to do is take this y position, set it equal to 0 and solve for t. We will do that in about 5 minutes from now. And tell me, I want you to think now, if I want to obtain an equation for the horizontal range, how will we do that? What is the horizontal range? The horizontal distance traveled by the projectile. Well, remember, x equal to Vx0 times t, V0 cos theta multiplied by t. When this t is the time of flight, then this x will be the range of the projectile. Is that right? When this t is the time of flight, the projectile has come back to the same horizontal level. It has covered this horizontal distance given by V0 cos theta multiplied by t. This t is now the time of flight. Okay, so once you know this equation and this equation, you can solve any projectile problem. Alright, let's move on. Now, let me see if I can take you to a website. Now, again, let me acknowledge that all the animations and illustrations that I take from the web are not mine. I would like to acknowledge the hard work of those people. Now, here we have a very good animation to study horizontal as well as projectiles at an angle. We have a gun here, and the height of the gun can be changed by using this slider. The slider can be moved up and down to change the height. You can project it from the origin so that y0 equal to 0, or make y0 any desired value. And you can change the angle of projection by using this rotary kind of a switch. Alright? And you can measure the range, you can measure the time of flight. The time of flight will be measured. Alright, let's first of all look at the case of a horizontal projectile where the angle is 0. Alright, now the angle is 0, let's run it. There you are. Now you can see the projectile was projected horizontally. It moved horizontally as well as vertically, and the horizontal distance traveled is, now what is the distance traveled? It is given here, 122 meter, and the time taken is 3.91 seconds. Alright, let me ask you, I want you to answer this question. It traveled a horizontal distance 122 meter in 3.91 seconds. What is the velocity of projection? Did you get the answer? Well, since the velocity of projection is a constant, you can get the velocity of projection multiplied by the time will give you the x value. Is that right? So x divided by time will give you the velocity of projection. Okay, now let me raise it and fire it again and see whether you get the same velocity of projection. Okay, I'm going to increase. Alright. I'm going to use the sliding control to raise the gun to say 100 meter, that is y0, and let's fire it now. Alright. Now the horizontal distance now equal to 140 meter, and the time taken is 4.49 seconds. Now, is the firing velocity the same as before? I want to calculate that. What is the velocity of launching? What is the horizontal velocity? Which will be 140 divided by 4.49. Alright, let's experiment some angle projection. Well, let's reset it and change the angle. Let's say the angle is 20, well, let's make it 25 degrees. There you are. The angle of projection is 25 degrees. So, what do we have? We have a projectile projected from a height y0 equal to 100 meter at an angle of 25 degrees, and you have calculated the velocity of projection. Have you? I'll give you two values to calculate the horizontal velocity. I hope you have calculated and that value is with you. You know the velocity of projection, right? The velocity of projection is that 140 divided by, is that right? Now, if V0 is that velocity, it will have an x component V0 cos 25 degrees and a y component V0 sine 25 degrees. Is that right? Let's fire it. There you are. And now, this is the time of flight, 6.04 seconds. Now, the time of flight is the time taken for the y position to become 0. And during that time, it traveled at